Hello students, welcome to my channel Hallabool Physics. Okay, today's chapter is thermal expansion. Okay, question is arising, what does it mean by thermal? What does it mean by thermal? You know, thermal means heat. Thermal means heat. So expansion due to heat is known as thermal expansion. Expansion due to heat is known as thermal expansion. Now, expansion is of three types. Expansion is of three types. Yes, it may have one-dimensional expansion, may have two-dimensional expansion, may have three-dimensional expansion. Now expansion along the length is one dimensional. Expansion along the length is one dimensional. Expansion in area is two dimensional. Expansion in area is two dimensional. And expansion in volume is three dimensional. Expansion in volume is three dimensional. So there are three type of expansions are possible. Maybe one dimensional, maybe two dimensional, or maybe three dimensional expansion. One dimensional expansion in length, two dimensional expansion in area, and three dimensional expansion it is in volume. Now, solid possesses all three type of expansion. Solid possesses all three type of expansion, while liquid and gases possesses only volume expansion. Only volume expansion. Now, again question is arising, why solid possesses all three type of expansion and how liquid and gases possesses only volume expansion? Simple, we can take the example for that now. In a uniform solid thin wire, in a uniform solid thin wire, if it is heated, expansion will be one dimensional. Expansion will be one dimensional. In a square plate, expansion will be two dimensional. Expansion will be two dimensional. And in a solid sphere, expansion will be three dimensional. So solid possesses all three type of expansion. Solid possesses all three type of expansion, while liquid and gases possesses only volume expansion. Now again question is arising, how it is possible for the liquid and gases? Simple, liquid and gases occupies the space. Yes, liquid and gases occupy the space. Space is three dimensional. Space is three dimensional. So liquid and gases occupies the space. Space is three dimensional. That's why we are saying now here, yes, liquid and gases possesses only volume expansion. Only volume expansion. So solid possesses all three type of expansion, while liquid and gases possesses only volume expansion. Okay, now the topic is expansion of solid. Expansion of solid. You know, expansion of solid may be one dimensional, maybe two dimensional, or may also be three dimensional. You know, expansion along the length is one dimensional. Expansion along the length is one dimensional. Expansion in area is two dimensional, and expansion in volume is three dimensional. Now we can take some relations in a class here. You know, delta L is directly proportional to delta T. Delta L is directly proportional to delta T, and here delta A is directly proportional to delta T, and here delta V is directly proportional to delta T. You know, now temperature increases, length also increases. Temperature increases, length also increases. Temperature increases, area also increases. And if temperature increases, volume also increases. Now we can take some more relations. You know, delta L is directly proportional to L naught. Delta L is directly proportional to L naught. And here delta A is directly proportional to A naught. And here delta V is directly proportional to V naught. But these relations are not exactly clear here. How to say delta L is directly L naught, or delta A is directly A naught, or delta V is directly V naught? Yes, how to understand this part? With the help of the two diagrams we have taken on the board here. Now, yes, less original length, less will be the change in length, less will be the change in length, more original length, more will be the change in length, more will be the change in length after rise in temperature, after rise in temperature. So more original length, more will be the change in length, less original length, less will be the change in length. So what we are learning from these two diagrams here, delta L is directly proportional to L naught, delta L is directly proportional to L naught, delta A is directly proportional to A naught, and delta V is directly proportional to V naught. Now we can take here, yes, some important relation with the help of these two. Delta L is directly proportional to L naught delta T, and from here delta A is directly proportional to A naught delta T, and from here delta V is directly proportional to V naught delta T. Now we can simplify these relations here. Yes, delta L is equal to L naught, a constant term alpha into delta T. Yes, don't be confused by these two symbols here. Is a symbol of directly proportional and is a symbol of alpha, is a symbol of alpha. Now here delta A is equal to A naught, a constant term beta into delta T, and from here delta V is equal to V naught, yes, one another constant term gamma into delta T. Now question is arising here, what is alpha, what is beta, and what is gamma? You know, alpha is the coefficient of linear expansion, alpha is the coefficient of linear expansion, beta is the coefficient of superficial expansion, coefficient of superficial expansion. It is also known as coefficient of areal expansion, is also known as coefficient of areal expansion. Gamma is the coefficient of cubical expansion, or it is also known as coefficient of volumetric expansion. You know, alpha is for one-dimensional expansion, beta for two-dimensional expansion, and gamma for three-dimensional expansion. Now, what is delta L? You know, delta L is the change in length. Delta L is the change in length. Delta is the change in area, and this delta V is the change in volume, is the change in volume. Now we can take some more relations here. You know, delta L divided by L naught, delta L divided by L naught, it will become equal to alpha delta T, and from here delta A divided by A naught is equal to beta delta T, is equal to beta delta T, and from here delta V divided by V naught, delta V divided by V naught will become equal to gamma delta T, will become equal to gamma delta T. So delta V by V naught, it will become equal to gamma delta T. Now question is arising here, what is this delta L by L naught, what is this delta A by A naught, and what is this delta V by V naught? Yes, simple. This delta L by L naught is known as fractional change in length, fractional change in length. This delta A by A naught is known as fractional change in area, fractional change in area, and this delta V by V naught is known as fractional change in volume, fractional change in volume. It must be clear here, what is the meaning of fractional change? What does it mean by fractional change? Fractional change means change in dimension by original dimension, change in dimension by original dimension. Now, one more way we can discuss delta L by L naught, or delta A by A naught, or delta V by V naught. You know, there are three type of strains are possible. There are three type of strains are possible. One-dimensional strain, two-dimensional strain, and three-dimensional strain. One-dimensional strain means longitudinal strain, and two-dimensional expansion means areal strain, and three-dimensional expansion means volumetric strain. So this is known as longitudinal strain, is also known as longitudinal strain, is also known as areal strain, is known as areal strain, and this is known as volumetric strain, So it should be clear here, is change in length per unit length, is change in length per unit length, or fractional change in length, or longitudinal strain, strain is change in area per unit original area, change in area per unit original area, or fractional change in area, fractional change in area, or areal strain, or areal strain. What is this now here? Delta V by V naught is the change in volume per unit original volume, change in volume per unit original volume, or fractional change in volume, fractional change in volume, or volumetric strain, volumetric strain. Now, if we are multiplying by 100 on both sides, what happens here? We will take it now. Delta L by L naught into 100 is equal to alpha delta T into 100. We are multiplying by 100 on both sides. Here also, delta A by A naught into 100 is equal to beta delta T into 100. We are multiplying by 100 on both sides. And here, delta V by V naught into 100 is equal to gamma delta T into 100. Here also we are multiplying by 100 on both sides. Now, what does it mean by this here? Yes, this is known as percentage change in length, percentage change in length, and here is known as percentage change in area, and this is known as percentage change in volume. So some important relations we have developed here is a change in length, is a fractional change in length, is a percentage change in length for one dimensional expansion, is a change in area, is a fractional change in area, and is a percentage change in area for two dimensional expansion, for two dimensional expansion, and is the change in volume, is the fractional change in volume, and is the percentage change in volume for three dimensional expansion. Okay, one question is arising: for which condition diameter of a hole increases or decreases? For which condition diameter of a hole increases or decreases? Yes, we have taken two diagrams on the board here. Is a diagram at temperature T naught, is a diagram at temperature T. Now, this is the hole of a diameter D naught at temperature is T naught, and this is the hole of a diameter D at temperature T, at temperature T. Now, question is arising: for which condition diameter of a hole may increases or decreases? That part we have to discuss in a class here. Okay, I will take the diagram now here. This is the initial area of a hole, and this is the final area of a hole. So this is taken as A naught. Here is taken as A. Now first question is arising: what is the relation in between A and A naught? A and A naught. You know, delta A is equal to A naught into beta delta T. That relation we discussed in a class for two-dimensional expansion, for two-dimensional expansion. So delta A is equal to A naught beta delta T. What is delta A? Is the change in area, change in area. You know, change in area is always final minus initial area, always final minus initial area. So what is final area is supposed to be taken as A minus initial area is A naught, and this is equal to A naught into beta delta T, A naught into beta delta T. Now simplify this relation. A will come A naught into 1 plus beta delta T, 1 plus beta delta T. Now this is the relation in between the initial area of a hole and final area of a hole of a square plate, of a hole of a square plate. Now this A may be greater than A naught or A may be less than A naught, it depending upon the change in temperature, depending upon the change in temperature. What is initial area in terms of the diameter, in terms of the diameter, and the final area in terms of the final diameter, in terms of the final diameter. Yes, what is final area is equal to pi by 4 d square. Final area is pi by 4 d square is equal to initial area is pi by 4 d naught square, pi by 4 d naught square, and it is 1 plus beta is equal to 2 alpha, beta is equal to 2 alpha, beta for two dimensional expansion, alpha for one dimensional expansion. The relation in between alpha and beta, beta that is equal to 2 alpha, beta is equal to 2 alpha into delta t, into delta t. Now this pi by 4 cancel, pi by 4 cancel. Now we can simplify the relation. We can simplify the relation. D square is equal to d naught square into 1 plus 2 times of alpha into delta t. Now how to simplify this relation with the help of the binomial expansion? With the help of binomial expansion, 1 plus x to the power n, this is equal to 1 plus nx, is equal to 1 plus nx. Now this relation is in this form. This relation in this form, here 1 plus nx, here 1 plus 2 into alpha delta t, 1 plus 2 into alpha delta t. So this 2 is nothing but as n. Yes, 2 is nothing but as n, and alpha delta t is nothing but as x. So this relation in the form of 1 plus nx, in the form of 1 plus nx, we can convert into this form. We can convert into a form of 1 plus x to the power n. So how to convert in a form of 1 plus x to the power n? D square is equal to d naught square into 1 plus, yes, what we can write it now, 1 plus nx. 1 plus nx is 1 plus x, 1 plus x to the power n, n is equal to 2. So d square is equal to d naught square into 1 plus alpha delta t square. Now this is square, here is square, square will be eliminate. So d will become equal to d naught into 1 plus alpha delta t. So this is the initial diameter of a hole of a square plate, and here is the final diameter of a hole of a square plate. So diameter of a hole of a square plate may increases or decreases, depends upon the change in temperature. Depends upon the change in temperature. Yes, if temperature increases, what does it mean by this here? Here T final will be greater than T initial. T final will be greater than T initial. Yes, T final is greater than T initial, and what is delta T? Delta T is always T final minus T initial. If final temperature is more than initial temperature, then this delta T will be positive. Delta T will be positive. Now put the value of delta T in the previous relation. D is equal to D naught into 1 plus alpha into delta T. Delta T is positive. Yes, D is greater than D naught. From the relation it is clear here, this value is more than 1. This value is more than 1. If this value is more than 1, D will be greater than D naught. D will be greater than D naught. So the diameter of a hole of a square plate increases. Diameter of a hole of a square plate increases if the temperature increases. Now if temperature decreases, that is T final is less than T initial. T final is less than T initial. Now if T final is less than T initial, that is delta T is equal to T final minus T initial will be negative. This value will be negative. Now this negative value we can put in the previous relation of D is equal to D naught into 1. Yes, it is alpha delta T. 1 plus D is equal to D naught 1 plus alpha delta T. In this relation delta T is not positive, delta T is negative. So this delta T negative we can put here. D will become equal to D naught 1 minus alpha delta T. 1 minus alpha delta T. Now this is clear here. This value is less than 1. This value is less than 1. Okay, it means D is less than D naught. D is less than D naught. Now this is clear here. The diameter of a hole of a square plate may increases or decreases. It depends upon the temperature. If temperature increases, then the diameter of a hole of a square plate also increases. But if temperature decreases, then the diameter of a hole of a square plate decreases. Now the next topic is effect of temperature on the moment of inertia of a uniform rod. Suppose we are taking a uniform rod. Yes, these are two diagrams on the board. Here is a rod of length L naught at temperature T naught. Final length will become L at temperature T. So initial length of the rod is L naught. Final length will become L. If temperature increases, length also increases. Okay, here delta delta L is equal to L naught into alpha delta T. You know all students that relation, delta L is equal to L naught alpha delta T. What is delta L is equal to L minus L naught. Change in length is always final minus initial length. So final minus initial length is equal to L naught alpha into delta T, or L is equal to L naught into 1 plus alpha delta T. This is the relation in between the initial length and the final length of the rod. Initial length and the final length of the rod. Now, what is the initial moment of inertia of a rod? Suppose initial moment of inertia of a rod is I naught, final moment of inertia will become I. What is initial moment of inertia is I naught is equal to m into L naught square. I naught is equal to m into L naught square. This is the initial moment of inertia of a rod at temperature T naught. What is final moment of inertia of the same rod at temperature T? This is I is equal to m into L square. Mass does not change as temperature increases, length also increases. So initial length was L naught, final length will become L. Yes, final length will become L. This is the initial moment of inertia of a rod and is the final moment of inertia of a rod. Now the value of L we can take from here now. Take the value of L here. What is I will become equal to m into L is equal to L naught into 1 plus alpha delta T. Yes, it is whole square. Or I is equal to m into L naught square. I is equal to m into L naught square. It is 1 plus alpha delta T. It is whole square. Now this value we can simplify by binomial expansion. 1 plus x to the power n is 1 plus nx. This concept we can apply here for finding the moment of inertia. So I is equal to m L naught square into 1 plus, it is 2 alpha into delta T. 1 plus 2 alpha delta T. Now we can put the value of I naught from this relation. What is I naught is equal to m L naught square. So take this value here. Yes, a relation will converting into I is equal to I naught into 1 plus 2 alpha delta T. 1 plus 2 alpha into delta T. Now this is the relation in between the initial moment of inertia and the final moment of inertia of a rod. Yes, I is equal to I naught into 1 plus 2 alpha delta T. Now, what is I is equal to I naught plus 2 times of I naught into alpha delta T. Yes, multiplying inside it by I naught. Or this I minus I naught will become equal to delta I. And this is equal to 2 I naught alpha delta T. So the change in moment of inertia is equal to 2 times of alpha delta T. Now this delta I divided by I naught will become equal to 2 times of alpha delta T. What is this delta I by I naught is known as fractional change in moment of inertia. And its value is equal to 2 times of alpha delta T. Now multiplying by 100 on both sides, a relation will be delta I by I naught into 100 is equal to 2 times of alpha delta T into 100. Yes, what is this delta I by I naught is known as percentage change in moment of inertia. So some important relations we have taken on the board now. I is equal to I naught into 1 plus 2 alpha delta T. Change in moment of inertia is equal to 2 times of I naught alpha delta T. Fractional change in moment of inertia is equal to 2 alpha delta T. And the percentage change in moment of inertia is equal to 2 alpha delta T into 100. Now the relation in between the density and the temperature of body, yes, body is taken as a sphere, is taken as a sphere, is the initial volume of a sphere, is the final volume of a sphere. Now what is the initial density of a sphere is rho naught, is rho naught is equal to m by v naught, m by v naught. V naught is the initial volume of a sphere, v naught is the initial volume of a sphere. What is the final density of a sphere is supposed to be rho is equal to m by v, m by v. V is the final volume of a sphere, v is the final volume of a sphere. Now you know one relation we discussed in a class, delta v is equal to v naught into gamma delta t, into gamma delta t. What is delta v? Is the change in volume, is the change in volume, always final minus initial volume. What is final volume is v minus initial volume is v naught is equal to v naught into gamma delta t. Yes, you may simplify this relation. V will become equal to v naught into 1 plus gamma delta t, 1 plus gamma delta t. So this is the relation in between the initial volume and the final volume of a sphere, of a sphere. Now this value we can put in this relation. Put the value of volume in this relation. Yes, rho will become equal to m by v is equal to v naught into 1 plus gamma delta t, 1 plus gamma delta t. Now this m by v naught is equal to rho naught, m by v naught is equal to rho naught. So what is rho? Is equal to rho naught, rho is equal to rho naught divided by 1 plus gamma delta t, 1 plus gamma delta t. Or we can simplify now, rho will become equal to rho naught, it is 1 plus gamma delta t, power will be minus 1, power will be minus 1. Now this is in the form of binomial equation, is in the form of binomial equation. What is binomial equation? 1 plus x to the power minus n is equal to 1 minus nx, 1 minus nx. Now this part we can apply here to simplify the relation. Rho will become equal to rho naught is 1 minus gamma delta t, 1 minus gamma delta t. So this is the relation in between the initial density and the final density of a sphere, is the initial density and the final density of a sphere. Now again question arises here, what does it mean by this negative sign? Negative sign represents as temperature increases density decreases. Negative sign what represents? As temperature increases density decreases. Now some more simplification relation we can take it now here. Yes, what is coming relation? Rho is equal to rho naught into 1 minus gamma delta t, 1 minus gamma delta t. We can simplify, rho will become equal to rho naught minus rho naught into gamma delta t, or this rho minus rho naught is equal to minus rho naught into gamma delta t. Yes, this rho minus rho naught is nothing but a change in density, change in density. So what a change in density is equal to minus rho naught into gamma delta t. So this is the value of change in density. Negative sign what represent? Temperature increases, density decreases. Temperature increases, density decreases. Now this delta rho divided by rho naught, delta rho divided by rho naught will become equal to minus gamma times of delta t, minus gamma times of delta t. So this delta rho by rho naught is known as fractional change in density, fractional change in density. Now multiplying by 100 on both sides, delta rho divided by rho naught into 100, this value will become equal to minus gamma delta t into 100. Multiplying by 100 on both sides, that relation will converting into the percentage change in density, percentage change in density. So some important relations we have taken in a class here. Final density rho is equal to rho naught 1 minus gamma delta t. Change in density is minus rho naught gamma into delta t. Fractional change in density is minus gamma delta t, and the percentage change in density is minus gamma delta t into 100.